Hello everyone, today we'll be taking a look at IPv6 NAT. Similar to IPv4 NAT, IPv6 NAT is an address translation technology but designed for IPv6. The use of IPv6 address is becoming more and more common due to exhaustion of IPv4 address. When formulating IPv6 technical standards, the ISO recommends that IPv6 NAT should be avoided because it compromises the end-to-end reachability of the Internet. However, NAT has unique technical advantages in scenarios, such as maintaining IP address independency on edge networks, and the network multi-homing. Two issues may occur during network planning and design. First, network designers may not want to replay internal network addresses when changing between telecom carriers. And second, they may be unfamiliar with planning and deploying internal addresses and routes when the network connects to multiple carriers. In such cases, network designers will resort to using NAT in the IPv4 era. The same is true for IPv6. There are two IPv6 NAT technologies, NAT66 and NPTv6. Similar to NAT44, NAT66 is a stateful address translation technology. It translates between two IPv6 addresses using the store translation mapping. NPTv6 is a stateless address translation technology. It uses a specific algorithm to implement bidirectional translation between IPv6 addresses. The translation device does not need to solve the calculation relationship between the two addresses. Because NAT66 has similar shortcomings as NAT44 in deployment, it has not become a formal international standard. In contrast, NPTv6 overcomes the shortcomings of NAT44 and has become a formal international standard. Next, let's talk about how NPTv6 works. An IPv6 address consists of a prefix and the interface ID. Unlike NAT66, NPTv6 translates only the prefix of an IPv6 address, using an algorithm that keeps the IPv6 address checksum unchanged. It processes interface ID in order to achieve one-to-one mapping between two addresses. So, how does this algorithm work? Assume that the prefix and the interface ID of the original IPv6 address are A and B, respectively. X is the checksum of the IPv6 address consisting of an A and B. And C and D are the prefix and the interface ID of the target IP address, respectively. We need to ensure that checksum of the two IPv6 addresses remains unchanged. That is, the checksum of the IPv6 address consisting of A and B is equal to that of IPv6 address consisting of C and D. It is a one-to-one linear relationship. This simple algorithm implements one-to-one mapping between two IPv6 addresses. When data flows pass through the NPTv6 device, the device uses this algorithm to implement bidirectional address translation. NPTv6 does not need to maintain the mapping between two addresses, improving the efficiency of address translation. With NPTv6, network planning and design personnel can use private IPv6 addresses to plan internal networks. When a user needs to access the carrier network, the carrier assigns a public IPv6 address to the internal network. An NPTv6 device can be deployed between the internal and the external networks to interconnect them. To enhance the reliability of the border between the internal and external networks, you can deploy multiple NPTv6 devices to work in master backup or load balancing mode. By deploying NPTv6, you can ensure that internal network IP addresses are independent of each other. If an external carrier needs to be changed, you only need to change the address mapping rules on the border NPTv6 device. Furthermore, if multiple carrier networks need to be accessed, different address mapping rules can be deployed on different NPTv6 devices. for multiple homing deployment or internal network. When deploying NPTv6, pay attention to the following points. First, NPTv6 supports bidirectional access. That is, the internal network and the external network are reachable to each other. In this case, you need to deploy a firewall at the network border and filter external data packets to ensure internal network security. Second, because NPTv6 changes the source or destination address of a data packet, it is not compatible with technologies that provide IP header integrity check, such as IPsec. Third, similar to NAT44, NPTv6 changes the original IP address in packets. If IP address-aware application such as FTP exists on the network, technologies such as ALG must be deployed to ensure proper running of these applications. This technology ensures independency of edge networks and effectively handles scenarios in which they are dual home. Network designers can determine whether to deploy NPTv6 as required. That's all for this video.